Uh, Hello, my name is Ramon da Silva. I am a PhD student at Pontifical Catholic University of Paraná in Brazil. And today I'm going to present you the paper entitled Solar Power Forecasting based on ensemble learning methods. So the agenda of this presentation is going to be the introduction, the objectives, the material, the methods, the methodology, the results, the conclusion, as well the acknowledgements. So the fossil energy have been a process of transaction to the use of clean energy. This is because of fossil energy is running out and because of environmental reasons. The choice of solar energy is due to the fact that it is a growing energy source. It is found abundantly, free and clean everywhere in the world. However, to forecast solar power generation time series, it is challenging because there are several variables that generate uncertainties. For example, weather, temperature, seasons, and for that reason, it is necessary to develop an efficient forecasting model as accurate as possible. Therefore, ensemble learning approach deals with these uncertainties and can help improving the forecasting accuracy. The objectives of this paper is to forecast solar power generation one step ahead. And the specific objectives is applying regression approaches, developing a model to forecast solar power generation, identifying suitable machine learning techniques, and improving the forecast accuracy of solar power generation. So this dataset is about a photovoltaic plant located at Artigas in Uruguay. The samples were obtained every 10 minutes from April 14th in 2018 at midnight until April 16th, 2018, 11:50 p.m., with a total number of 432 samples. And the dataset was split into training and test sets, 70 and 30%. And the system inputs and outputs are the temperature and radiation as inputs, and the power generation as output of the system. So the methods used in this work are the stack ensemble learning. We're gonna call stack. The models used in the stack method is the cubist, the multivariate adaptive regression splines, the MARS, the linear model, the Bayesian regularized neural network, and support vector regression with linear and radial basis function kernel. And this dataset was also pre-processing using two different techniques: the PCA, the principal component analysis, and the core, the correlation matrix. And the models was evaluated using relative root mean square error, the determination coefficient, and the symmetric mean absolute percentage error. And for statistical tests, Diebold-Mariano test was used. So the steps for developing the proposed model is to take the data set, then training, pre-processing the pre-processing the data set using PCA and core, and then training each of the data sets using the models. This makes the layer 0 of the stacking. Then the predictions are pre-processed again using PCA and core, and then trained to use the meta learners, the SVRR, and the QBIS in the layer 1. So as we can see in the table below, the core models presented better results than PCA models. This is because due to the fact that core removed the high correlated features. So the combination core LM linear model obtained better results of the single models at the left side of the table. And the core qubits stack model obtained best results of the stack models at the right side of the table. And comparing best single and stack models, the core LM presents better performance. We highlight the best performance in bold in the table below. So that model, the model core LM, presented the best criteria, as you can see in the previous table. So in this table, we can see that the model reached the lowest statistical error than comparing models at 1% of significance level. And so the statistical tests are highlighted in the table in the red box. So in conclusion, in this case, all single models presented better results when compared to stack models, obtaining satisfactory values in all performance measures. And the single model core linear model obtained the best results of them all in all three performance measures. And as proposed for future research, we're gonna use different algorithms for both layers in the stack, increasing the number of steps to forecasting, and using other renewable energy sources such as wind and biomass for competitive studies. As acknowledgements, we'd like to thank you, CAPES, CNPq, Fundação Araucária e PUC-PR for financial support this work. And we'd like to thank you so much for watching this presentation. I wish you the best and goodbye.